Trigonometry, Chapter 1, Trigonometric Functions, Section 3, Trigonometric Functions, Video 4, Example 1 of the 6 trigonometric functions. I have 2 more examples after this. This series is based on content from Pearson's Trigonometry 12th edition by Lial, Hornsby, Schneider, and Daniels. Oops, back. There we go. Okay, in the previous video, we were introduced to the 6 trigonometric functions. If theta is in standard position, vertex at the origin, initial side on the positive x-axis, and x comma y is a point on the terminal side of theta, not the origin though, and r, the distance from the origin to the point x comma y, is the square root of x squared plus y squared, then sine of theta is y over r, cosine of theta is x over r, tangent of theta is y over x, and the reciprocal functions, cosecant of theta, the reciprocal of sine, is r over y, secant theta, the reciprocal of cosine is r over x, cotangent theta, the reciprocal of tangent, is x over y. You need to have these memorized. I will say that all the time. Let's take a look at an example. Suppose the point 8 comma negative 6 is on the terminal side of theta. Find the values of all 6 trigonometric functions of theta. Well, we're given x equals 8 and y equals negative 6. We need to calculate r. That's pretty straightforward because r is the square root of the sum of the squares of x and y. So to calculate r, we'll square 8, we'll square negative 6, add the results and take the square root. When I square them both, I get 64 and 36. If your calculator tells you that negative 6 squared is negative 36, then you are not using your calculator correctly. Notice how I put the negative 6 in parentheses. That's because if I didn't and put this in a calculator, the negative would not get squared. When you square a negative number in a calculator that you type, you need parentheses around the negative. Anyway, square, add, and we get that r is 10. Great, we got all 3 pieces. So all we have to do is set up all 6 of these ratios. Substitute all the numbers. Again, this is pretty straightforward. All the y's become negative 6s, so watch the y right here become a negative 6. Watch this y become negative 6. And this y down here become negative 6 as well as the one down here. All the x's become 8s, so top of this fraction, bottom of this fraction, bottom of this fraction, top of this fraction. And all the r's becomes 10s, bottom of cosine, bottom of sine, top of cosecant and secant. So just substitute all the numbers, and now we have a bunch of fractions that need reducing. Don't leave a negative inside of a fraction. It's not wrong. You can leave it that way, but it just looks better in front. However, unreduced fractions are considered unfinished. So your final results are sine of theta is negative 3/5, cosine of theta is 4/5, tangent of theta is negative 3/4, cosecant of theta is negative 5/3, secant of theta is 5/4, cotangent of theta is negative 4/3. Yes, that's all there is to this particular problem, which means it's time for you to try. Pause the video and try the following problem. Suppose negative 14 comma 48 is on the terminal side of theta. Find the values of all 6 trigonometric functions of theta. Pause the video and give it a try. Okay, here's your warning. Last chance to pause and try. Solutions in 3, 2, 1.